Okay, hello, year 9. What is up? This is a recording for our August week 4. Okay, sorry for my absence. I was not feeling well last Friday, so this is the replacement video. I hope you take the time to watch everything, and if this is too boring for you, you can put a ×2 speed and watch everything. Okay, so today mainly we will finish the exercise first. All right, so last week we finished our chapter 9, the middle part here, which is air pressure, if you still remember this. All right, so like I said, pressure always goes from high to low. Pressure is generated when air particles, they collide with the wall of container. They bang on the wall of container, so they generate pressure. All right, so two factors that affect pressure. You have your volume. The higher the volume, the bigger the room, the less pressure you feel. Okay, the higher the temperature. If I heat up the room, you run faster, so the larger the pressure. Okay, so pretty common sense here. And of course, you have atmospheric pressure in daily life. All right, so this is the same thing. Pressure goes from high to low. So we apply it in our plunger, we push the thing out, high pressure to low, the Magdeburg hemisphere. You cannot separate this because the pressure is pressing on it. Straw, siphon, syringe, these three, they are almost the same. Okay, they work almost the same way. And then you have your vacuum cleaner. They blow air out with low pressure, so pressure higher outside will push the dirt in. And of course, you have pouring milk from a can. You have to make a hole here so that air pressure can go in and push the milk out. All right. So anyway, let's continue with our exercise because last week we finished around here. So let's look at number 10, which is page 18. So we have a straw here. As you can see, there's a hole here. Well, as you know, if there's a hole here, we are not going to suck this thing up. All right. So Suling wants to use a straw to drink from a glass, but she could not suck the water. She finds a small hole on the straw, suggests a method to overcome this problem. All right. So why can this thing not work? Because when you suck here, atmospheric pressure will enter from here, but not push the water in. That's why the hole doesn't work, right? So what do? You can tape the hole, or you can say cover the hole with tape. Okay, please don't say change a straw. That doesn't work. I want you to solve the problem, not to change the whole thing. All right, so how do you explain this? Because now atmospheric pressure cannot enter the straw via the hole, but push the water into the straw. Right, a long explanation here. So that means atmospheric pressure, they will not go in here, but they will push the water in. So there's no shortcut for the pressure to go in because you tape the hole up. All right, so next. Lalita is preparing tea for her guests. She has noticed that the condensed milk is difficult to pour out of the can, as in the figure. So like I said, there's only a hole here, so it's very small pressure here. This place has small pressure. So atmospheric pressure is high. Pressure go from high to low, so the pressure will, stuck the small hole and your condensed milk cannot come out. So how Lalita can overcome the problem? She can make a hole at the top, okay, which is around here. So why? Because atmospheric pressure enters the can via the hole, so milk can be poured out. Okay, that means the pressure will enter here. This is the similar concept as this, right? Because pressure goes in here. In this case, we don't want this to happen, but in this case, we want this to happen so that it can push the liquid out. Okay, so it's a similar concept. Next, number 11. So this is a siphon. Okay, this is a siphon. So as long as you fill the siphon with liquid, pressure will go from high, outside is high. They will try to enter the tube because inside has no air, so it has it has low pressure. So inside here has low pressure, outside has high pressure. So it will push this thing out. This is what we call a siphon. Okay, so what is the function of a siphon? Siphon is to transfer liquid. All right, it is to transfer liquid from one container to another. All right, so if you have petrol, do you know this is how people steal petrol from your car? All right, if they manage to open your, I mean, with any way possible, if they manage to open your fuel cap, you know, the place where you put your petrol, if they manage to open it, they use a siphon, they can siphon your petrol from your fuel tank. So this is how they steal your petrol. All right, hopefully it doesn't happen to you, because in this case you have no more petrol in your tank and you need to replace your fuel cap. Okay, that would suck. Okay, so B. What is involved in the working of a principle besides air pressure? Okay, so okay, this is a bit out of syllabus. So besides air pressure, what makes siphon work? You see, this is higher, this is lower, right? This is like a waterfall. Water will go from high to a low ground. So what is this concept? This is gravity. Okay, gravity. So siphon, they work using air pressure and gravity, because gravity will pull the liquid down. Okay, so C, based on your answer in B, explain how it creates a difference in air pressure, causing the liquid column to move continuously from A to B. All right, so explain based on gravity, explain how it creates air pressure. Okay, so let's just say the tube lah, huh? Okay, so firstly, the tube is filled with liquid. So inside, okay, pressure, or you can say air pressure in the tube is low. Right, you have low pressure inside the tube. So atmospheric pressure, which is higher, it pushes liquid into the tube, just like a straw. All right, because when your straw is filled with liquid, inside is low pressure. So the atmospheric pressure push the liquid into your straw. This is the same thing. Okay, so D, can the siphon work well if both beaker A and B are placed at the same height? Explain your answer. All right, so about this siphon, if both cups, both beakers are at the same height, this thing won't work. It's like waterfall. If water is at the same ground, same height, will water go from A to B? No, it won't. All right, no. Okay, because there is no height difference. You can say height, or you can say gravity difference. Okay, so siphon is a bit a little bit of air pressure concept, a little bit of gravity concept. So both works. Right, so E, suggest an apparatus or equipment that also work on the same principle as the siphon. Like I said, you can say the straw, it works the same way. You can say syringe, it works as the same way too. It's to push liquid into a tube. So next, F, when he went home, Faris was told by his mother to clean a fish aquarium. He wanted to try to remove the water in the aquarium to a bucket using a siphon. He tried several times but still failed. As you can see, they are almost at the same height, I think. So this is why they don't work. State a mistake that might have caused the siphon not to function. All right, you can say the bucket and the aquarium are at the same height. right? They are the same height, so that's why water can't flow, just like this. Okay, so one needs to be higher and one needs to be lower. So number 2, explain how a siphon can function by relating to the principle of air pressure. So this is the same explanation as up there, which is here. Okay, you can actually write back the answer here. You just change the, right, you don't need to change anything because it's the same explanation. Okay, so I'm going to skip this because it's the same answer, same question and same answer, same principle. So next, number 12, study the diagram below and answer the following question. Okay, so where is high pressure, where is low pressure? Right, this is last week. Okay, so inside there has low pressure, outside has high. That's why the high pressure press on this thing, it's very hard for you to pull it up because of the high pressure. So same thing, high pressure here. Inside is low pressure. Again, he didn't ask for it, but just to let you know. So B, the diagram below shows a syringe filled with medicine. Okay, so this is the same as your straw. So what should be done to draw the medicine into the syringe? You can pull this thing. You can call this a plunger or you can call it a piston. Okay, pull the plunger or piston. So number 2, what will happen to the air pressure inside the syringe when the medicine is drawn into the syringe? So when you pull up, pressure inside is low because outside pressure high, only they will push the medicine into the syringe. Just like your straw, just like your siphon, same thing. So what will happen to the air pressure? It will decrease. Why? They didn't ask why, but just to let you know, when you pull up, the volume inside increase. As you know, when volume increase, when there's more room here, the pressure will decrease. Okay, a bigger room, you feel less pressure. Okay, so because the volume in the syringe increase, so pressure decrease. All right, so anyway, next, so this is what happens. Okay, this is a very interesting experiment. So what do? First, you boil water in a can, okay? So when you boil water, right, since water is boiling, right, water will evaporate very quickly. This thing will push all the air out. All right, this thing will push the air out. So now when inside has very little or no air, you quickly cover it. You quickly cover it. So inside is it's like very low pressure really because you push all the air out. And then when you pour cold water, remember when I said about temperature, when temperature decrease, pressure decrease. When it's cold, there's less pressure. So when this thing becomes cold, the pressure will drop even lower. So the atmospheric high pressure will press on this can and you will crumple the can. Okay, so this is something to do with temperature. So C, in school, Faris carried out an activity to show that air produces pressure as shown in the diagram. Explain why the can becomes dented. All right, so you can say steam pushes air out of can. So you have low pressure in the can. Okay, so when cold water, okay, you know what? I try to cut my answer short. So cold water decreases pressure in the can. So higher atmospheric pressure presses on the can or crush the can. Okay, so atmospheric pressure is pretty strong. If you do this using an oil barrel, Okay, you can go and search this on YouTube. If you use a big oil barrel like the 200-liter oil barrel, you do the same thing will happen. It will crush the can, no problem. Okay, so as long as there's a pressure difference, you can create the same thing. Excuse me. Okay, anyway, so number 13. So Jasny and his friend join a hiking expedition of Mount Kinabalu. They carry food supplies such as bread and chocolate to the mountain's base camp. The diagram below shows the side view of a packet of bread at the camp. So, right, this question actually we did this last year, but I doubt you remember. Right, anyway, so let me quickly explain this again. So when you are at the base camp, remember, the higher your altitude, the lower the pressure. Okay, this is why on a plane, your surround has low pressure. That's why they need to pressurize the cabin. Okay, so before taking off your plane, they need to seal the plane and they need to pressurize inside. If not, you cannot breathe. Okay, because the pressure is too low up there. So this is why climbing mountains are like Kinabalu or Everest for that matter. It's not for the weak. Okay, if your heart and your lungs are very weak, you're not going to adapt. You might die up there. Okay, so just be careful. So what happens here? Okay, so at the mountain base camp, you should have the same pressure. Okay, because this packet of bread is made on the ground. Let's say the factory, let's say this is Gardenia. Gardenia factory is on flat ground. When you're at mountains base camp, you're also on flat ground. So the pressure is the same. So you don't really feel anything. This is like, the same. So when they're at the base camp, okay, when they're at the base camp, so which area has higher pressure, it will be the same. Okay, because the altitude, okay, remains the same. Okay, that means this pressure inside and outside is the same, right? Assuming that the base camp and the bread factory has the same altitude. So now, when she started climbing, okay, so the diagram below shows the position of Justy and his friend at different location of Mountain Kinabalu. So the friend, she climbed up already, so you see, much higher. So here has lower atmospheric pressure. Okay, so compare the atmospheric pressure at R with the atmospheric pressure at S. So the pressure at S is higher than R. So this is why it becomes harder to breathe here. Because you see, if let's say this is your lungs, I think I explained this last year. If this is your lungs, if outside pressure is very high, like in R here, the pressure will be pushed inside your lungs easily. But if outside pressure is low, like in S here, there's lower pressure, so less air is pushed into your lung. So it's very hard to draw air into your lungs. So this is why at a high place here, you feel like you're running out of breath. This is what we call altitude sickness. Okay, because there's less air pushed into your lungs, you feel there's less oxygen, you feel sick. Okay, lack of oxygen, we call it hypoxia. It's a lack of oxygen. So this is why your plane, if you're on a plane, the windows need to be shut. If you accidentally break a hole, let's say your plane has an accident, part of the plane is punctured, okay? This is where you get hypoxia. This is why if you have been on a plane before you take off, the air stewardess, they say, if there's an accident, they will drop a mask down. That you need to wear the mask to breathe, because that mask will keep oxygen on you. Because if not, if you have an accident, if your plane puncture, there's not enough pressure around you, you will get altitude sickness and you will die. Okay, so you need to put on your mask. Okay, so based on the principle of air pressure, explain the condition faced by Justin at location S compared to his friend at location R. Okay, so what is faced by her? So now you have lower atmospheric pressure than R. Okay, so you can say less air is pushed into lungs. So you will get altitude sickness. Okay, so D, state the relationship between altitude and atmospheric pressure. So as I said just now, the higher the altitude, the lower the atmospheric pressure. Okay, so that's why up there, that's very low pressure. This is why pilots, fighter pilots, they need to wear that special mask to keep the pressure. If not, they will faint. Okay, so E, diagram above shows the same bread taken to adjusting to a high altitude. What happens to the packet of bread when she arrives at high altitude? So you can say the packaging becomes full. Now inside has high pressure because the surrounding pressure is already lower. So now this pressure higher, right? It will push on the packet. So now the packet feels tight. The same thing happens when you go to Genting. Okay, so let's say you have an empty water bottle in your car. When you reach Genting, the bottle becomes full. So when you open, you hear the sound. The pressure just goes outside because inside is very full. Because when you are in KL or Selangor, you have normal pressure in the bottle. So when you go to Genting, Genting is very high up there. So lower surrounding pressure. Inside the bottle has higher pressure, so it feels tight. Okay, so if you come down from Genting, it's the reverse. So if you have an empty water bottle in Genting, okay, when you reach KL, by the time you reach KL or Selangor, the bottle will be crumpled. Because inside low pressure, same as Genting. When you reach KL, higher surrounding air pressure, higher atmospheric pressure, it will crush the can. Okay, so anyway, so the packaging becomes full. So let's explain, okay, because you have lower atmospheric pressure than inside the packaging, okay, the packet, and pressure inside the packet, sorry. So now pressure in the packet presses outward. So now you have a tight packaging. Okay, so you know what, guys? You know, due to me not feeling very well, I will continue with this moment thing, you know, the next week, okay, which is September week 1. All right, so this part here, okay, pardon for the short video. Okay, I will finish this by next week. Okay, don't worry. And we might go into a new chapter as well. Okay, so anyway, thanks for watching this video. I hope this video is helpful. Okay, I will see you again the same time next week. Okay, so do see you. Take care. See you and bye-bye.